Welcome back, ladies and gentlemen. As you can see, we are going to be taking a look at the first of our curved position time graphs and their conversion into a velocity time graph. So, much like before, we have to cut up the graph, but the cutting is going to be more important this time in some ways because those curves are going to make things interesting. Now, I have given you three criteria for cutting up a graph: crossing the axis, change of slope, change of shape, and change of sign. Shape, slope, same thing. Here's the thing. Everyone's going to cut this up a little differently. And depending on how you cut it up, depends on what will work or what will make sense in your answer. All of the graphs should look roughly the same, but they won't look exactly the same. Case in point, I could take a look at this and go, okay, I'm going to say that from 4 to 5, this thing is flat. You could say that because if you look close at your graph, from 4 to 5 seconds, it definitely reaches a valley of some form, like a flat section, a trough. You could then declare that from 0 to 4 seconds is all one giant curve, and that is a very reasonable thing to declare. But you could take it a little bit further, because what you could do is go, if I cut it, say, here, all that stuff sort of beforehand, sort of, let's say, between about 0 to 2, that could be considered a sloped line. Maybe. And the advantage of this, of course, is that it makes a lot of the math easier. But you don't have to do that. In point of fact, most people probably won't. And cutting it up there maybe doesn't necessarily make things better, but it is an option. This is often going to be the case. There are going to be lots of individual places that you can cut things. And where you choose to put the marks depends on your choices. And those choices will give different results. And those results will be subtly different. That doesn't mean they're wrong. And if you make sure to explain what you're doing and why you're doing it, and you showcase all of this, then you're fine. I will accept those answers. If there's a test and you show me how you cut up the graph and that's what you work with, that's what I will mark. That's how it goes. Anyway, we've cut up the graph. Now we've got to find some numbers. Now, because this is a curved graph, it's going to be hard for me to write all of this on the board. So I do have the copy of the book here, and I'm going to be looking them over. So that first X section there, maybe from, let's say 0 to 2 seconds, right? We'll call that section 1. Again, we don't have to, but we're going to do that. So this is going to be section 1, and our 1 here is going to be, from the looks of it, it's going to be 7 or so, -7 minus, and it's at 2 seconds, and it goes down to 0. Okay, so 7 divided by 2, and I forgot to grab my calculator. Oh, no, there it is. 7 divided by 2 is a nice 3.5. I'm not sure why I needed a calculator for that. Maybe I'm a little tired today. So -3.5 meters per second. Okay, then we're going to do section 2. Now, section 2 is a curved segment. So a curved segment is going to require a tangent line. Reminder, tangent line to find the instantaneous velocity. And that's what we're going to do. We're going to find what the instantaneous velocity is at a point somewhere in there. Now, obviously, again, this is a graph on a board. A graph on a board is not going to have the necessary grid lines for me to be able to do this. So I've done this on a piece of paper. But I'm showing you here how I would roughly do it. I would choose a point, let's say there, and I would put a line such that it only touches the graph at that point. And I can make the line as big or as small as I need or want in order so I can find 2 spots on that line, let's say there and there, that happen to be easy numbers for me to work with. So the 2 spots that I ended up finding, which gives me my answer for 2, I got, let's see, when I worked it out, I decided that I liked the look of spot -6. Yeah, I like the look of spot 0 over 5. So 0.5, so like over here I said was on the axis, so 0.5. And I liked 1.6. Okay, so there we go. We've set it up. Now we've got to pay attention to the positives, negatives, because this is clearly going to be a negative slope, which is going to check out here because we're going from -5 down to -6. So it's a pretty shallow slope, like there's not a lot going on there, right? So it's going to be 6 plus 5, oops, 6 negative plus 5, get our nice -1, divide by 1. So this is going to be ourselves a 1 meter per second negative slope. Okay, pretty simple so far. We have a slope, it's clearly going down, that part's easy. For section 3, it's just going to be 0. Section 4, we're going to need another tangent line. So once again, I take out my trusty marker. I'm going to draw a tangent line, even though it's not very helpful on the board because the board doesn't have any grid lines. So once again, you're going to take it and you place it, you choose a spot, so I'm going to say there, and you place it such that it touches only at that spot. And you can make it as big or as small as you want. And then you find 2 spots, maybe it's those 2, right? Yeah, I could find one spot on one side, one spot on the other, but it can be any 2 spots. Doesn't matter, you choose. And then I use those 2 spots to solve for my slope. So when I chose 2 spots, I ended up choosing 8, 6, or -6, and 11, -2. So it's going to be 11 minus 8 for the time, and -2 minus -6, which means, of course, this is going to be a positive slope, which makes sense because that line there is clearly positive. So we're going to get 4 divided by 3, give or take, 4 over 3. We're going to want to turn that into a decimal, 1.25. I'm not going to trust it. Too tired today, apparently. So it's 1.33. All right, I was close. And by close, I mean not even close at all. 1.33 meters per second positive. Now again, reminder, these 2 here, number 4 and number 2, these are the instantaneous velocity of specifically the points that I selected. The 2 points that I selected on my graph here were at point about 3. So that was at time equals 3. And the other one I selected was at time equals 6. That'll become critical later when we're drawing the graph. All right, we can do the rest of this now. Section 5 is going to be from here up to there. So I should put some numbers on here so people remember which ones are which. 4, this whole section is 5. Up here, we'll put 6, and here we'll put 7. So for 5, we can choose any 2 points. That top one there is at about 11.5. It's not very nice to work with a half number. So again, I'll just look at my grids here and try to find some numbers that work a little better. Oh, I like this one better. 11, I am clearly at 8. So we're going to go with times 11, and we are at plus 8. That's my final. And I subtract my initial. Yeah, the axis looks pretty nice. The axis there is at 9, and we're looking at 0. So yeah, this is just going to be a nice, simple plus 4 meters per second. Now, I'm applying that particular value for this entire length from here to here. I did say cut at the axis, but as I mentioned last time, that's more to do with calculating area than slope, so you don't always have to do it, and today I'm not going to do it. I'm going to cut it up like this with bigger sweeping pieces. If you decide to cut it up at the axis, it'll be fine. You'll still get a graph that should be, broadly speaking, correct. Section 6 is going to be 0. And then finally, section 7 is going to be this line that goes all the way down. And we see here that our final point is going to be at about, 20, -3, all minus, we started up at 10. Where is that? 10. That's close to 16. 16 and 10. So we're going to get -13 divided by 4. 13 divided by 4 equals -3.25 meters per second. Again, I am not cutting this below the axis and this above the axis as 2 separate things. I'm just going to treat it as all one thing. I'm just being a little lazy today, I guess you could say, or to be accurate, a little bit more precise. Okay, so now we just need to work through the shapes, just like we did last time. We'll go backwards because the ending is going to be much easier than the beginning. So that's a sloped line. Now, from our pattern that we've seen multiple times now, we go with curve, becomes sloped, becomes flat, becomes dead or zero line. So our first one there is a sloped line. So that is clearly going to become a flat line. And it's going to be a negative flat line in some way because that's a negative slope. 6 is going to be a dead line because it's not moving, aka it's a flat line now, so it becomes a dead or zero line next. Section 5 here is clearly a sloped line, so that's going to be a flat line, and it should be a positive flat line because it's a positive slope. Now, 3 is also going to be easy. That's going to be another dead line. 4 and 2, hold on that. 1, well, we said that was a slope section. We said that was just a slope, a negative slope, so we're going to get just a negative flat line. Now, for the last 2. The last 2 are curves, and in this basic pattern, curves become slopes. Now, the question is, of course, which way do I draw the slopes? How am I going to do this? Well, here's the thing. It's going to become very obvious once we start drawing the graph. This is often a trick that you can use. When you're working with any kind of curves, it always makes things more difficult. But if you pay close attention, you can usually take a couple shortcuts. So let's get our graph up here. You know what? Let's make sure we have lots of space. I'm trying to remember exactly how big this graph is. Okay. So take it down. We take it over. Ruler fell a little bit. That's okay. I think it's still very legible. Stick the ruler over here. So we're looking at up to 20. All right, so we'll say 5, 10, 15, 20. That's about even. And then for height, remember, we don't care what the height is on this graph. We care what the maximum height is on the numbers that we calculated. So I got a 3.5 there. I got a 1.3 here. I got a 4 there. And I got a 3 1/4 there. So basically from positive 4 to negative 4. So 1, 2, 3, 4. 1, 2, 3, 4. All right, we've got our scale. Let's start recording our numbers. Our first number here, it says, is going to be at negative 3.5. And that is located for that first segment, which ended at, I chose, what time did I choose for that segment? I chose 2, I think. I chose 2. So 2, negative 3.5, so that's about there or so. Okay? So now we've got the curve, and I said leave the curve for now. The curve we'll come back to. Then we've got section 3. Section 3 is from about 4 to 5, and I said that was 0. So it's going to be a flat line, a dead line, right like that. Okay. We're going to skip 4, and we're going to take a look at 5. So 5 is 4, positive 4, and we check here, section 5 is this huge section here, which I ended up cutting at about, where did I put that? At about 8 till 10, 11, give or take. So 8 will be about here, and 8 to 11, so we're saying that it's going to be up here at about plus 4, like so. All right. Yeah, that's about right. Then we continue. For section 6, it's going to be a dead line again. It's right on the axis, and that's happening at about 11. And that's going to continue until about 16 or so. So that's a nice long stretch of flat there. That one's easy to put in. Finally, we have that last section there. It's going to be at negative 3.5, sorry, 3 1/4, so about here to there. And there we go. We've got all our dots. Now we have to connect those dots. Well, this last one is a flat line, so that one's super easy. We just go straight across, and I can connect it going down like that. The one here is 0, and then we've got another flat line, and that flat line is going to be at plus 4, and it's going to go from, as I said, 8 to 10, so, or 8 to 11, so we're looking at something kind of like that, straight across, and I take it down. So this is what we call a stepwise graph, because it looks like a set of stairs. All right, now for the hard part. Slopes. The curves turn into slopes. What type of slopes do they become? Well, we know that at time equals 6, we're at positive 1.3. So time equals 6 is about here. 1.3 is about there. We know that is true. We also know that I have to draw a single sloped line, and that sloped line must go through this spot. It must start here, and it must end there. Gee, I wonder what the line will look like. It must be a single line. It must start and end in the same basic place. Now the problem here, of course, is that I'm doing this a little freehand, so my dot didn't quite line up. But there we go. Something like that. Similar, what's going to happen with this one? Well, we know that we have to be 3.5 at the start, and that 3.5 has to be flat. So, something like that. We also know that at about time equals 3, so that's 4, so about 3, I have to be at position 1. About there. So again, I lined this up just a little bit wrong. This one here has to be back just a touch because it's supposed to be at 2, so about there. I put down my ruler, and I connect my dots. And what I see is that all the different little lines line up. The curves turn into slopes, but we know what the slopes have to go through. The slopes have to go through the numbers that we find, and they have to connect up with the rest of the graph in some way, because that's how a slope works. Now, obviously, here we don't have direct connections because there are no slopes here. Here we do. Now, your graph might look subtly different depending on how you cut it up. So, for example, people who didn't cut up one to cut 1 off of 2 and just kept this as all one curve, instead of getting a graph that looks like this, you might have gotten a graph that looks something more like this. Because, just finish up here. There we go. This smoother line is what happens when you keep it sort of all as one continuous piece. It's still basically saying the same information. We just discretely pulled out certain elements like this, and this. It's also possible, depending on exactly where you drew the tangent line and exactly how you did the math, that you might get numbers that are different than my -1 and positive 1.3. The first time I did this graph, I got both the slope for section 2 and 4 to be exactly the same. And that just comes down to how you draw your tangent line. The tangent line it's more of an art than a science. You learn the best ways to put together some tangent lines. And to be honest, I think my first tangent line could have been a little better. But that is okay. The key thing here is about sort of getting that practice. And so long as you have roughly that shape, or I should rephrase that, so long as you have roughly the shape that corresponds with the cuts you made, you're fine. If you made these cuts on the graph, I should expect to see a graph that's kind of like that one there. If you made different cuts, I might see a different type of graph. The key thing is you showing me what you got and how you got it. So there you go. This is what the curved graph turns into. Once again, I will remind you, looks very different, doesn't it? And that's very normal. We usually get very different types of graphs. All right, there it is. That's how to do that last one there on page 43. You guys have another graph on page 44. Page 45 is about doing this pattern, this conversion backwards. That usually takes a little bit longer to do. That's 45. If you continue flipping to page 48, you will find there's a mix of practice, right? So for example, page 48 itself is another position graph that I ask you to make a velocity graph of. But page 49 is a velocity graph that I ask you to make a position graph of. The reason for that is, of course, that's the other part of this unit that we haven't yet learned. So you are going to be jumping around a little bit when it comes to the practice here. My apologies for that, but you know, the last time that I printed these booklets, we weren't in a shutdown-ish situation. So things are a little bit unclear. If it asks you to find anything to do with area, you won't be able to do it. But if it asks you to do anything that involves slope, you can do it. As for the area notes, I will put out that video probably tomorrow. So then you guys can get looking at that and see how to do it without too much trouble, I hope anyway. Yeah, so I'm going to leave it there, and I will see you guys next time.